is DOH-NANI from the Department of Statistics and Actuarial Science, Kenya University. Today we are going to talk about a simple topic on elective maths, or some other call it pure mathematics, named trigonometric ratio and rules. But before then, kindly subscribe to this channel, click on the notification bell below so that at any point you will be the first to notice my new videos when I upload them. Kindly share and also comment, like it as well. Yeah, so as I said earlier, we are going to treat the topic trigonometric ratio and rules. But before then, I would want us to talk about angles so that it will aid us in the explanation of the further topics. So with angles, there are basically 5 angles. We have the acute angle, we have the right angle, we have obtuse angle, we have straight angle, and finally reflex angle. And with the acute angle, it's an angle that falls between the 0 degrees and the 90 degrees. So considering this diagram, we have a two-dimensional plane. What I mean by two-dimensional plane is we have the y-axis and then the x-axis. An angle forming here from if a straight line is drawn from the origin out, it forms an angle. And this angle lies between the 0 and the 90 degrees. The 0 and the 90 degrees. We can talk about the right angle. The right angle is also exactly 90 degrees. Exactly 90 degrees. So if we consider this diagram over here, see that the x-axis and the y-axis, there is an angle forming, and it is exactly 90 degrees over here. That is right angle. We can talk about the obtuse angle. So for the obtuse angle, it's an angle that lies between 90 degrees and 180 degrees. So considering this diagram, we can find out that with a two-dimensional plane, now the angle forming here lies between 0 and the 180 degrees. So it can be found somewhere, 90 and then 180 degrees, 90 and then 180 degrees. So we can find the straight line drawn from what? The 0, from the origin somewhere, where the line falls between the 90 degrees and then 180 degrees. Now, angles are measured anti-clockwise. That is basically the reason why the angle has been drawn this way. Positive angles are drawn anti-clockwise. So, having a clock, we know that clock moves in a direction this way. But for anti-clockwise, that's how for anti-clockwise it moves in the opposite direction of the clock. Now, moving on to the straight angle. Straight angle is an angle that is exactly 180 degrees. So considering this diagram, we can see that moving from the 0 mark to 180 degrees. So this is a straight angle. This is a straight angle. Now the reflex angle. Finally, the reflex angle is an angle that falls beneath 180 degrees and 360 degrees. So an angle that falls between 180 degrees and 360 degrees is said to be what? A reflex angle. So considering angle theta ends up at here. That's between 270 and then 360 degrees. It is a reflex angle. This angle is said to be a reflex angle. And this is also said to be a reflex angle because it lies between 180 degrees and 270 degrees, which are all between 180 degrees and 360 degrees. Now, to Pythagoras, the trigonometric ratio, moving out from the angles to trigonometric ratio. A great mathematician called Pythagoras brought out a theorem. So now we've heard about Pythagoras Theory. Pythagoras Theorem happens to deal with a right angle triangle, always happens to deal with right angle triangle. here is my right angle, and there's a triangle forming, and there's an acute angle. So basically, trigonometric ratio is dealt with an acute angle. So wherever you find on a circumference an acute angle forming, then trigonometric ratio can be established with that acute angle, regardless wherever it is found. So if an acute angle is formed between the 180 degrees and 270 degrees, then we would basically work with that acute angle, which forms a right angle triangle at that particular range. So with Pythagoras, he defined the long stretching line from that meets the end points of the axis, the x-axis and the y-axis, to be the hypotenuse. And this is the opposite. That is the line that is opposite to the angle, and the line opposite adjacent to the angle adjacent. So we just bring it a short, just rewrite it in short way. Now, this is a trigonometric identity, sine theta, cos theta, and we are going to find a corresponding ratio. So with trigonometric identity sine theta by Pythagoras shows that sine theta is opposite over the hypotenuse, and this is my opposite over the hypotenuse, forming a ratio of what? A distance BC over AC. That's this distance. We do consider the distance. However, if the distance is falling farther from the 90 degrees, so here it says with the negative, the positive. Here is the positive and negative. So if however this triangle is drawn in this direction, we will deal with the distance and add the appropriate sign to it. That is, we wouldn't say a distance is negative, but due to the considering the two-dimensional plane, the origin, any line moving farther from the origin to the left is negative. So we measure the distance and we add the appropriate sign to it. Now, cos theta is the adjacent over the hypotenuse. So cos theta is adjacent over the hypotenuse, and the ratio is x over r. So here is measured x, any value x. So, and then tan theta is what? Opposite over the adjacent. That is y over what? X. So basically, y over what? X. That's the trig ratio for us. Now, there is a simple acronym or mnemonic that would aid students to always remember these ones. That is, we have the sine opposite over the hypotenuse to be so. That is, the sine theta is opposite over the hypotenuse, SOH. So then we have cos theta, so adjacent over hypotenuse, so CAH, CAH. Then we have the tan theta to be opposite over adjacent, that is TOA, that is TOA. So basically we keep it in mind, so CAH TOA, so that in all times students may remember them. Thank you.